So next law is gay-Lussac's law of gaseous volume. Okay, so is name denotes this law given by gay-Lussac. So we can write this law given by gay-Lussac in 1808. So according to this law, when gases react with each other in simple ratio of their volume, and if product also present in gaseous state, then the volume of the product is always bear a simple ratio to the volume of gaseous reactant at similar conditions of temperature and pressure. Okay, so we can write the statement of this law. So according to gay-Lussac, gases react with each other in simple ratio of their volume, and if product also in gaseous state, then the volume of the product, the volume of the products is also bear a simple ratio to the volume of gaseous reactant, at similar condition of temperature and pressure. Okay, so according to gay-Lussac, gases react with each other in simple ratio of their volume, and if product also in gaseous state, then the volume of the product is also bear a simple ratio to the volume of gaseous reactant at similar, or we can say the same conditions of temperature and pressure. Okay, so let's take an example. If we write hydrogen react with chlorine and they form HCl. Okay, so here if hydrogen present in gaseous state, chlorine also in gaseous state, and their product also in gaseous state. So if we balance this equation, here 1 mole of hydrogen react with 1 mole of chlorine and form 2 mole of hydrochloric acid. Okay, so here if 1 volume of hydrogen which reacts with 1 volume of chlorine and form twice volume of HCl. Okay, so we can write they have simple ratio of their product with their reactants. So we can write 1:1:2. Okay, so ratio will be 1:1:2. So this is the simple ratio. If we write another example, if nitrogen reacts with hydrogen and form ammonia. Okay, so here if we balance out this equation, 1 mole of ammonia reacts with 3 moles of hydrogen and they form 2 moles of ammonia. Okay, so if nitrogen in gaseous state, hydrogen also in gaseous state, and their product also in gaseous state, so here we can write 1 mole reacts with 3 mole hydrogen and form 2 moles of ammonia, or we can write it 1 volume of nitrogen react with thrice volume of hydrogen and form twice volume of ammonia. So their simple ratio will be 1:3:2. So this is the simple ratio. Okay, now we are going to discuss the next law, that is the Berzelius hypothesis. Okay, so we can write here next Berzelius hypothesis. Berzelius hypothesis. So if we talk about the Berzelius, he is the Swedish chemist and he also suggests, yeah, we can say he given the modern symbols of our elements which is we used in chemistry nowadays. So that all symbols are given by Berzelius based on their English name or their Latin name initials. Okay, so here we are going to discuss Berzelius hypothesis. So according to Berzelius, under the similar condition of temperature and pressure, if equal volume of gases are taken, then all the gases contains equal number of atoms. Okay, so this is the very simple statement we can write. According to Berzelius, under the similar conditions of temperature and pressure equal volume of all gases contains equal number of atoms. Okay, so this is the statement given by Berzelius. So we can write an example. If hydrogen reacts with chlorine, it forms twice HCl, as we discussed in previous law. So here one volume of hydrogen reacts with one volume of chlorine and form twice volume of HCl. Okay, so we can say that here an atom, here n atoms of hydrogen react with n atoms with chlorine and form twice n atoms of HCl. Okay, yeah, we can simplify it. If one atom of hydrogen react with one atom of chlorine and form two atoms of HCl. Okay, so we can write, if we take half atom of hydrogen which react with half of atom of chlorine and form one atom of HCl, but this is the against of the law of, yeah, we can say Dalton's atomic theory. We can't divide it an atom in half, 1/4, 1/3 in these ratios. Okay, so this hypothesis failed, and this hypothesis corrected by Avogadro. Okay, so we can write these values are in against of Dalton's atomic theory. Okay, so these are the different laws as we discussed. They have a great role in chemistry to understand the further concepts. Okay, thank you.